Hi, I have Tyler and Melissa videos for you about this homework, but I just wanted to add a short summary of what they're about to tell you myself. This is a picture of water dissolving salt. So the negative is the chloride ions and the positive is the sodium ions. Now when water dissolves salt, or when water dissolves any ionic compound, you could see from this picture that the positive ions get separated from the negative ions. This isn't fully dissolved yet, but when this is fully dissolved, there will be no negative ions touching positive ions. Every ion will be completely surrounded by water molecules. That's how water dissolves ionic compounds. This is one reason why when salt dissolves in water, the water seems like it can conduct electricity. That's true for any ionic compound. If water dissolves it, that new solution is more conductive to electricity than it had been before. All right. Now, there's a big difference with how water dissolves sugar. So this big purple thing is a sugar crystal, and each hexagon here is one sugar molecule. So when water dissolves sugar, or when water dissolves any covalent molecular compound, no ions, when water dissolves something like this, you see the molecules separate one at a time. This sugar is not completely dissolved yet, but when it is completely dissolved, every molecule, every purple hexagon will be surrounded by water molecules. These blue and red things are water molecules. So this is a huge difference compared to the ionic compound. In the ionic compound, this one is NaCl. The Cl minus and the Na plus are separate from each other. But in the covalent compound, each molecule is not separated, but each molecule is separated from the other molecules. So here we have one molecule at a time floating in the water. But here we have one ion at a time floating in the water. So what does that mean? That means that suppose you have something a little larger, like let's say, suppose you have something like sodium sulfate. Suppose you have something like sodium sulfate. If you dissolve this in water, you're going to get two sodiums dissolved in water plus one sulfate dissolved in water. All right? That's a lot of stuff dissolved in water. However, if you dissolve something like let's say glucose, you know, the simplest sugar, the sugar that plants make. If you dissolve glucose in water, you're gonna get just glucose dissolved in water. I know in the lab you did this anhydrous calcium chloride, and you dissolved it, and it was an exothermic reaction like this, like that. This is just a simplification. This is not exactly what happens. What really happens is you get a calcium ion and you get two chloride ions. Right? Now Melissa is about to tell you in the video that I put on the canvas that this here, this right here, this is called the molecular equation because it treats everything as molecules. Even though they're ionic compounds, they are written as molecules here. This here, this right here, what I'm circling now, this is an ionic equation because everything that is written here is written as it really appears in the water. So calcium ions appear in the water, not calcium chloride as a molecule, but they get separated as ions. Okay. Here, let me give you a couple more examples, and then I'll let you watch Tyler and Melissa. They do a great job. All right. So let me show you a little chemical equation that you did yourself. In our last lab, you did this chemical reaction. You did iron 3 chloride and sodium hydroxide, and you made iron 3 hydroxide which was a solid, and a sodium chloride, which was aqueous. And balance this right quick. All right, so this is what you did in the lab in one of your experiments. Now, this is the balanced molecular equation. I've written everything here as though they were molecules. But you know, NaCl does not stay together in water. It separates. So if I want a accurate equation that shows exactly what was happening in the water, I would write the total ionic equation, or the complete ionic equation, right? Let me see if I can get a different color for you for this. What about this color? All right. Is that? Yeah, that's better. So for the total ionic equation, you didn't even have FeCl3 in the water. You actually had Fe3 plus ions in the water, because water separates ionic compounds if they're soluble. You also had chloride ions in the water. But how many chloride ions did you have? You had 3 of them. Now putting a 3 here shows you had 3 chloride ions, and they were all separate. 3 things floating around by themselves in the water. If you put a 3 down here, that means something else. That means you had clumps of chloride ions floating all together in the water, which is not what happens in our universe. Right, now here you have 3 sodium ions floating all separately in the water, and here you have 3 hydroxide ions floating all separately in the water. And when you mix those all together, you got FeOH3. Why am I drawing this all together instead of separately? Because you saw this as a dark brown or dark orange or dark red jelly-like solid. This is a jelly-like solid. It was not all separate and floating around. It was solid all together. So that's how it actually was in your test tube. Right now, the rest of this was 3 sodium ions floating around all separately in the water, and 3 chloride ions floating around all separately in the water. Now, this is the total ionic equation, or the complete ionic equation. This gives you the most accurate picture in your mind of what was happening in your test tube. However, let me show you something here, which Melissa is going to show you again also. Where's the mouse? Where did it go? Oh, here it is. Let me show you something here. I'm going to cross out with purple. Let me show you. You see this iron in the this iron in the reactants? Does that appear in the products? No. Fe3 plus doesn't appear in the products. Fe appears as FeOH3, which is not the same as Fe3 plus. What about this chloride? 3 chloride ions appear in the products? Yes, here they are. 3 chloride ions in the products and 3 chloride ions in the reactants. So what happened to the chloride ions? There were chloride ions in the reactants and there were chloride ions in the products. What happened? Nothing happened. Nothing happened to the chloride ions. Let me just cross these out because nothing happened. Sodium ions. 3 sodium ions in the reactants, 3 sodium ions in the products. What happened to the sodium ions? Nothing happened. So let me just cross those out. Hydroxide ions. 3 hydroxide ions in the reactants and no hydroxide ions floating around in the products. All the hydroxide ions are stuck to iron ions. Okay, so that's different. Something different happened to hydroxide ions and something different happened to iron ions. You see the things that I've crossed out? The things that I've crossed out are the things that appear exactly the same way in the reactants and the products. Nothing happened to those ions. Those are called spectator ions. Melissa's going to tell you this again. It's also in the textbook excerpt that I pasted for you in the Canvas. These are called spectator ions. They're called spectator ions because, just like you when you go to a baseball game, you don't play the game, you watch the game. And that's what these guys are doing. They're not playing, they're not getting changed, they're just along for the ride, just watching. Now, when you remove the spectator ions, you have a new chemical equation. Here, let me write this chemical equation for you again. So I'm going to write this. I'm going to copy the same thing down without the spectator ions. All right. copying things down. That's all I'm doing. I'm just copying things down. You think I'm thinking? I'm not thinking. I'm just copying things down. All right. So it's iron, hydroxide, iron 3 hydroxide. That's it. You know what this is called? This is called the net ionic equation. This is called the net ionic equation. So for this homework, whenever you see an opportunity to write a chemical equation, I suggest you write the molecular equation to balance the equation. This is the easiest equation to balance. And then I suggest you write the total ionic equation to get a clear picture of what's happening. And finally, I suggest you write the net ionic equation. In this homework, anytime there is a chemical reaction in the problem, I suggest you write all 3 equations. It's the best way to understand and to get the right answer. Thanks.